In this video, Hellier College math students, we're going to move into calculating areas of plane figures. So basically, we're going to do all sorts of different shapes. We've just discussed in the previous videos how to calculate the area of a triangle using 3 different methods. So now we're going to focus on the other types of shapes that we'll come across. So rectangles, squares, parallelograms, a trapezium, circles, and sector. So a lot of these will be really familiar to you guys, especially rectangles and squares. You'll have seen circles and know that the area of a circle is pi times the radius squared, and so forth. So we're going to try these examples here. And the first one is a parallelogram. Okay, now if we look back, this is really easy. It's the base times the height. I just want to explain a little bit how that works. Why is this seemingly somewhat complex shape, why is it so easy to work out the area of this shape? Well, if we examine this more closely, let's say that I was to chop off part of this parallelogram. What if I wanted to go here and just chop this bit through here, bang. So this bit here, right, I'm going to take this, I'm going to chop it off, and I'm going to put it over here. Now you can sort of see, oh, that's not very good, I'll give that another go. I'll use a ruler. You should always be using rulers, you guys. And that's why, because it looks a lot better. Okay, so that black piece is now over here. Okay, so let's make it go away here. So it's gone from this spot here now, and you can see that what we end up with is a rectangle which is 9 by 7. So the area A is simply the base times the height, just like a rectangle. So for that one we get 63 square centimetres, 9 by 7. So parallelograms are really easy to work with. They're just a lot like rectangles and squares. Now this trapezoid here has an interesting formula. If we look back, we've got these lengths A and B on the top and the bottom, so the top length and the bottom length. We seem to be adding those up here and multiplying them by a half. That's interesting. I wonder why we would do that. Well, let's see. Let's apply a similar idea as to the trapezoid. I'm going to cut this piece off this time. I'm going to cut here. So this piece here, I'm going to cut this black piece. And just like before, I'm going to take it and whack it over here. And you can guess what happens. We make another rectangle. Right. So, let's make that look like a rectangle. So we'll scrub out this piece here. That's gone. We put it over the other side. Whoops, look out. Here we go. Okay. And now we've got a rectangle. Now clearly the height of this rectangle up this way is 2.3 metres, but what is the side length? Well, they're not 2.8 and 4.4 anymore. They've changed. And to find out what they are, we take those two side lengths, add them up, and average them. So 2.8 plus 4.4, and if we halve that, we're finding the average. So doing that bit, that's part of the formula, as you can see over here, doing that bit gives us this side length of the triangle. So that gives us 3.6. Right? So this is simply a triangle a rectangle that's 3.6 by 2.3. So if we take that number and multiply by 2.3, then we get area equals, well, that gives us the area, right? And we should be getting 8.28 square meters. So very interesting the way you can manipulate these two shapes into rectangles and get the area of those two. They're really similar to rectangles. Okay, so probably a little less complicated now is finding the area of these circular type shapes. Here we've got a full circle. Okay, so area equals pi r squared. So pi multiplied by the radius squared. Okay, practice putting that into the calculator. Make sure you can get the correct answer. If you're not sure what to do, get me over. But the answer is 167.42 square meters. Now, here we've got a bit of a slice of pizza here. Well, we call it a sector. That would be a nice big slice of pizza if you were to take that one from the pizza pie. Really similar to arc length. Remember we discussed arc length earlier? We're finding the distance along a curved part of a sector. Well, in this case, we want the entire area in here. So if we were just going to consider this as a full circle, we'd just say pi times 27 squared, pi r squared. But it's not a full circle. We need to find out what fraction it is, and it's really similar. Well, it's exactly the same as if you were doing an arc length. You take the angle that's subtended on the sector, 138 degrees, and divide it by 360. As simple as that. So, see if you can put that one into the calculator and get the right answer. And the right answer is 877.92 square centimetres. Now, in the book, you're going to come across all sorts of different composite shapes, ones that we haven't covered in this example. And there's a lot of different ones, so it'll take a long time, really long video for me to do them all. I'm going to need you to try them yourself and just, give it a go. But of course, I'm there with you. So if you need me, get me over in class and I'll go through anything that you're stuck on with you.